Okay, so I figured it would be a good idea to give you another example of mass stoichiometry. And actually, this is kind of a nice sneak preview of a lab that we're going to get to do at the end of the year, probably around the beginning of June or so. And the goal of that lab, and it's pretty intimidating on the surface, but you're going to learn everything you need to know to do it before then, is to produce exactly 2.00 grams of something. You're going to have a lot of different choices as to what you can actually produce, but it kind of tests all of the skills that we've done all year. A little stoichiometry, a little mole stuff, a little balancing equations. So don't let it freak you out right now, because you got plenty of time to figure it out. And basically, the calculations that you're going to have to do in that lab look a lot like what we're seeing here. Now, this isn't one of the specific reactions that you're going to be dealing with, but let's say, for example, that you want to produce exactly 2.00 grams of MgCl2, magnesium chloride. Now, to do that, you're going to react magnesium sulfate, which is this one that I've underlined in black here, and aluminum chloride, which I underlined in blue. And again, your products are going to be magnesium chloride and aluminum sulfate. It's your basic double replacement reaction from way back in the day. So, again, if we want to produce exactly 2.00 grams of magnesium chloride, how many grams of each reactant will we need? So we're going to have to do two separate calculations here. One for magnesium sulfate, and I'll start with that, and one for aluminum chloride. So, again, let's go through the steps. When we're dealing with mass stoichiometry, first step is always to get a balanced equation. We have one, so we're going to skip that. Now, the next step, and I'm going to check that off because I'm about to do it, is to convert the grams of the given substance to moles. So, I have 2.00 grams of MgCl2. That's my given substance. So, I need to convert that to moles. And I need to do that using the molar mass. The same thing we've done all year long, ever since we learned it the first time. Now, it just so happens that the molar mass of magnesium chloride is 95.21 grams. And then we put 1 mole, as always, on top when we're converting between moles and some other unit. So, we get to cross out the grams, and we're left with moles on top. Now, we're left with the moles of magnesium chloride. Now, the question asks us about the two reactants. So, we're going to start with magnesium sulfate, the one that I underlined up there in black. So, first thing we got to do is, again, we have to use the mole ratio. That's so important in stoichiometry, to convert to the moles of the desired substance. So, our mole ratio comes straight from the balanced equation. Now, on the bottom, we're going to have the moles of the given substance, the one that we started with. In this case, it was MgCl2. So, the coefficient I see in the equation is a 3. So we're going to go ahead and put 3 moles of MgCl2. That's going to cancel out those moles that we wanted to. And then, on top, hey, looky there. We happen to have the same number of moles of magnesium sulfate. Anytime you see this, just like when we were figuring out the formulas for ionic compounds earlier in the year, they cancel out. And so, essentially, you've got a 1-to-1 ratio. However many moles you have of one substance, you have just the same number of moles of the other. So, pretty sweet. We've basically saved a step here. Now, we can't forget to get the mass, because in the lab, in this particular lab that you're going to do, you're actually going to be measuring out a specific mass of each reactant. And if you get that mass wrong, then there's a very good chance that you won't get the 2 grams of your substance that you want to get. So, in this case, we need to use the molar mass of the desired substance to convert from moles to grams. So, just so happens that the molar mass of magnesium sulfate is 120.38 grams. And we have 1 mole on the bottom. So, we end up getting an answer of 2.53 grams of magnesium sulfate. So that's one calculation. We figured out how many moles of magnesium sulfate we need. So if we go in the lab and we grab a weigh boat and we check out the balance, we're going to put in enough magnesium sulfate to get to 2.53 grams, and then we're going to use that. So, next step. we're going to do the same thing, except now we're going to do it with aluminum chloride. So, first part of the equation is going to look identical because we still are dealing with the 2 grams of magnesium chloride that we started with. So, next step is to get the moles of that. And again, anytime you convert between grams and moles, it's all about the molar mass, baby. I'll never say that again, I'm sorry. And then our next step is to use the mole ratio, and this time it's actually different, so it's a nice change of pace. We've still got the 3 moles of magnesium chloride on the bottom, nothing changed there. But now we've got 2 moles of aluminum chloride on the top. I'm afraid that I'm crowding a little bit, so I'm going to try to slant this down a bit. I apologize. And finally, we're interested not in knowing the number of moles, because you can't measure moles on a balance or a scale, but you can measure grams. So we're going to go ahead and get the molar mass of aluminum chloride, and we're going to use that to convert. Now, the molar mass of aluminum chloride happens to be 133.33 grams in 1 mole. So our math is going to look like this. I'll go back and cancel out the units that I can cancel, which should be all but the last one. So we end up with grams of aluminum chloride. And our math is going to be 2 divided by 95.21 times 2 divided by 3, and we have to account for both of those since they're not the same, and then multiply finally by 133.33. And the answer we get is equal to 1.87 grams of AlCl3. So, this is a bit of a brain teaser, and this is going to be difficult the first couple times you try it. It's going to seem kind of like a foreign language, but again, remember, the only thing that's different is that mole ratio. If you can remember to use those mole ratios along with everything else you've learned and most of you have mastered at this point, you're going to be okay. Stoichiometry is not a big scary thing despite its big scary name. So hopefully this will help you get started, and we'll go from here. Thanks for watching.